Miss Long. I'm a 6th grade science teacher at Gibbs Middle School. I want to start today by saying I miss my students so much, and I'm sure that each of your teachers miss you guys just as much. Again, this is the 6th grade science week 5 lesson. You can find all of the activities and materials for this lesson on the KCS website under the Student Resource tab and inside of the week 5 packet. Printed copies of the packet are available at the meal distribution sites on Wednesdays from 10 a.m. to 12 p.m. if you need one of those. If this video is hard to understand, turn on closed captions if they're available, adjust the playback speed to slow down the video, consider watching short clips and then pausing, listening again, or watching again. Ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and about what you understood. As we get started today, I wanted to make you guys aware of the standard that we're going to be focusing on. So our standard for today is 6LS 2.3, which says draw conclusions about the transfer of energy through a food web and an energy pyramid in an ecosystem. We have 3 learning targets or goals for today's lesson. The first one says, I will track the flow of energy throughout a food chain. The second, I will track the flow of energy throughout a food web. And the third and final goal for today is I will apply my knowledge of the 10% rule in an energy pyramid. Before we get started on today's work, I want to spend some time talking about what you've learned over the last couple weeks and reviewing some of that material. So in your KCS at home lessons, you guys have talked about types of energy and broken down the 2 categories of potential and kinetic. You know that potential energy consists of chemical, gravitational, nuclear, and elastic energy, while kinetic energy consists of mechanical, radiant, sound, electrical, and thermal. You've also spent some time working on energy transformations. I know a bunch of you built Rube Goldberg machines, and that's one of my favorite science topics. A Rube Goldberg machine is a perfect way to watch energy transform from one step to the next. And we remember that when any energy transformation is happening, we have to apply the law of conservation of energy. And that states that energy cannot be created or destroyed. It can only change forms. Last week, you kind of took a break from energy and talked about biomes. And when you talked about those biomes, you discussed the abiotic and biotic factors within an ecosystem. Today, I want you to remember that abiotic means without life. It's something that's never lived, never will be alive, and it didn't come from something alive. Whereas biotic is something living, something that's once lived, meaning it's dead, or it came from a living thing. We're going to use all of this information that you've learned so far to take it a step further and look at energy transformations within an ecosystem. Before we can get into energy transforming in an ecosystem, we need to look at the roles of organisms in an ecosystem. There are a couple different roles, and we can sort them into 2 main categories: producers and consumers. A producer is something, usually a plant, that uses energy from the sun through photosynthesis, whereas a consumer is an organism that gets its energy from feeding on other organisms. There are a couple different types of consumers. You have herbivores, who are only plant eaters, carnivores, who are only meat eaters, omnivores, that eat both meat and plants, decomposers, which eat dead things and take that nutrients and give it back to the soil, and then scavengers, which eat dead things and trash, a little bit of everything. So with that in mind, how do you guys think that producers and consumers get and share their energy? Take a minute and think about it. If you need to pause the video, you can do that now. I think the best way to figure out how producers and consumers get their energy is by looking at a food chain. So energy transformations within an ecosystem are really easy to break down if you start with a food chain. A food chain helps us track energy as it moves from one organism to the next within an ecosystem. So for example, you have a food chain on your slide here that shows the sun, grass, a mouse, a snake, and an eagle. And we're going to follow the energy that started with the sun all the way through to the eagle. Each box in between each of your images represents the transfer of energy from one point to the next in the food chain. We have to remember as we go into place our arrows in those boxes that your arrow should point in the direction that energy is moving. So, for example, we know that the sun is the source of all energy. So the sun is giving its energy to the grass, which means the arrow should point away from the sun but towards the grass. That shows us that the sun gives its solar energy to the grass, and the grass uses that to do the process of photosynthesis before the energy is then given to the mouse. So if you want to take a second and fill yours in, you can check it against this example at the bottom. The example at the bottom shows that the sun gives its energy to the grass. When the grass is eaten by the mouse, the grass's energy goes to the mouse. The mouse gets eaten by the snake, which means it gives its energy to the snake. And then the snake eventually is going to get eaten by the eagle, which means that snake's energy goes directly to the eagle. As with any energy transformation, we know that we have a little bit of loss, not necessarily a true loss, but energy is transformed in a less productive way to heat energy or thermal. Now that we have a food chain and we understand how the flow of energy works through the food chain, we're going to take it a step further and look at a food web. So a food web is kind of like a bunch of different food chains. A food web represents multiple pathways of energy within an ecosystem. So it can show an animal that may eat more than one thing. You'll notice that on the image below, there are boxes and arrows this time. And then we have all of our images out to the side. We've also added two new organisms, a rabbit and a flower. So we need to start by figuring out, of those images, which two are our producers. I'm going to give you a minute to think about it. The two images in that picture that represent an organism that uses the process of photosynthesis would be the grass and the flower. So you guys are going to want to either draw or write in the words there in those boxes. From this point, you have to figure out who in your category to the left is an organism that only eats plants. So take a second to fill that out, and then you want to go to your secondary consumer. Your secondary consumer would be the option that not only eats one of your primary consumers, but also the other one. So they are eating two different things, and they're also eating a primary consumer, which earns its name secondary consumer. And then you guessed it, the next step is the tertiary consumer, which means third level consumer. So if you follow your food web through, or you break it down into even just a food chain, the tertiary consumer is the third level eater. I'm going to give you guys a minute to fill that in, and take a second, make your best guesses, and then we'll go over it together. If you want to pause this video now to give yourself some time, that would be a good idea. All right, let's review. So we already identified producers for our food web would be the flower and the grass. Of the choices to the left, your best options for primary consumers would be your mouse and your rabbit. Then you have to think about who eats the mouse and the rabbit. And while the eagle may eat both of those things, the snake is the only option left that doesn't also eat the eagle. So your snake becomes your secondary level consumer. And then you only have one choice left, and you can double check your work by thinking to yourself, is it reasonable that your eagle would eat the snake, also the rabbit, also the mouse? And if that's true, then your food web is correct. So we're going to take it one step further today, and we are going to talk about the 10% rule. The 10% rule is our way of understanding energy as it passes through an ecosystem. And we use an energy pyramid like the one pictured below to help us break that down and understand it more clearly. So on average, only about 10% of the energy from each level of your energy pyramid is passed on to the next level. 90% of that energy is lost to heat. We know that any transformation of energy, heat is a byproduct of. When you think about eating yourself, your body is warm, you're going through those steps as your body breaks down food, and there is some heat lost, even for you as a human consumer. So looking at our food pyramid here, or our energy pyramid rather, you have your bottom level, which is your biggest portion, and it's going to be where your producers are. At that point, they have 100% of available energy. And then as you move up a level to your primary consumers, those consumers that eat the producers, you only have 10% of that available energy because 90% of your 100 starting point was lost to heat. So you have 10% left. And then you work through the remaining levels of the pyramid, taking 10% of what is available to you at that point. So we're going to practice this together and make it a little more clear. To practice, you're going to need a blank piece of paper, either a marker or a pencil, and 100 of any small item. Okay, I know for me, I looked around my house and I had this big container of little gemstones, and that's what I chose. I also looked at chocolate chips and Legos and things like that. So whatever you have 100 of, that's what you're going to want to pick. And the bigger your object, the bigger you're going to need to draw that pyramid to make everything fit. So on your paper, you want to go ahead and draw out your energy pyramid. You want to divide the pyramid into 5 different sections, and it should look something like this. Once you have that done and you have your 100 items, then we're ready to get started. So you may want to pause this video and take care of that now, and then come back when you're ready. All right, now that you're ready to move forward, you're going to place 100 of your object in the producer's box. Mine got a little crowded because my pyramid wasn't quite big enough. So I have some that are doubled up and layered, but I think you guys will still understand what we're trying to do here. I put all 100 of my items in that producer's box, and that represents 100% of energy available at that phase. So then we have to move to the next phase, and we're going to follow with the 10% rule. So I know that 10% of 100 is 10. You're right. So we're going to take 10 of that 100 units of energy and move it up a level. We have to remember that 90% of that energy is lost to heat. So if you will count my gems in my primary consumers, you'll see that I have exactly 10 units of energy. And that is what the primary consumers received from the producers. So our next step is to see what is 10% of 10, because that's what will go on to the secondary consumers. So 10% of 10 is 1. You're left with 1% in the secondary consumers phase. And again, 90% of that was lost to heat. So moving forward, it gets a little tricky because you need to take 10% of 1, which, shout out to your math teachers, means you're going to do some fractions. You'll have to brag about yourself later with that when you talk to your math teachers. Instead of cutting up my gems, I used a smaller gem to represent that 10th of 1. So moving to the next phase, that secondary consumer gave 10% of what was available, it's 1 unit of energy, to the tertiary consumers. And the tertiary consumers were left with 0.1%. Of that 0.1, they're going to give 10% away. Okay, this is stretching your knowledge of fractions and asking you to use a lot of math, and I understand that, but bear with me. So you are going to use 10% of that 0.1 and give that to your decomposers. So you're going even smaller. I had one last teeny tiny rhinestone that I used, and that is going to represent my 0.01% of available energy. If you look at the pyramid that we have right now, you'll notice that at each level, 90% of energy is lost to heat. That is something you have to remember in the 10% rule. 10% moves on, but it's 10% of what you have at that point. So 10% of 100 is 10. but 10% of 10 in that primary consumer's box is only 1. And if you look at it that way, you'll see that less and less energy is available at each level of your energy pyramid. Now that we've practiced the 10% rule with 100 units of energy, let's take it even further. Use your food chain from earlier, the one with the grass and the mouse and the snake and your eagle, and practice. So instead of filling in your triangle with those words that say producer, primary, secondary, tertiary, you guys can actually fill it in with grass, mouse, snake, and eagle. But I want to challenge you, and I want you to start with 1,000 units of energy this time. That's going to make your fractions a little bit easier, but you're going to have to start a lot bigger. So you may not have 1,000 of your item, and that's okay. But if you want to go big and try to use 1,000, I'd like to see. Your producer is the grass, so you want to start with your 1,000 energy units there, and then use the 10% rule all the way through the eagle. Once you've made it through, tweet your results and show us your final energy pyramid at KCS Science. All right, guys, that's all I have for you today. I had such a good time reviewing science from this year. I miss you guys dearly, and I know your teachers miss you as well. So don't forget to clean up and wash your hands. And we will see you next week for week 6 of KCS at Home.